Hello friends, in this video lecture we are going to study about binary search tree. The topic covered in this video lecture are the basic introduction of a binary tree and the basic operations performed on a binary search tree, which include searching, insertion and deletion. Start. Binary search tree is a node-based binary tree data structure which has the following properties. The left subtree of a node contains only nodes with keys lesser than or equal to the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. The left and right subtree each must also be a binary search tree. Now, let us try to understand with an example. We are taking an example of a binary search tree. What do we mean by the word binary? Binary means every parent node has two child nodes. In this binary search tree, this is called the parent node or the root node. This is called the left child and this one is called the right child. This whole part is called the left subtree and this part is called the right subtree. Now, we can see that in a binary search tree, all the elements present on the left side of the root node are smaller than the root node and all the elements present on the right side of the root node are greater than the root node. Now we can see that here, this is the root node. This one is smaller than the root node and this one is greater than the root node. Similarly, here it is the root node. This one is smaller than the root node and this one is greater than the root node. And the same is here. This is the root node, this one is smaller than the root node and this one is the greater than the root node. So this is a basic example of a binary search tree. Now we are going to study about the basic operations of a binary search tree, in which the first operation is the search operation. We are trying to understand the search operation with the help of an example. So, let us suppose that in this binary search tree we have to search the element 66. 66 is our search element. So, step 1, read the search element from the user. So, we will read the search element from the user. Then, step 2, compare the search element with the value of the root node in the tree. Before doing this, I would like to tell you that this is called the root node. These are called the internal nodes. And this are called the leaf nodes. Now, we will compare the search element with value of the root node element. So, our element is 66, which is not equals to 55. Then, if this is not true, then we will go to step number 4, which is then check whether the search element is smaller or larger than the root node element. So, we can see that 66 is larger than the root node element. So, If search element is larger, then continue the search process in the right subtree. Now we will continue the search process in the right subtree. So we have to search 63 which is larger than 55. So now we will continue our search process in the right side of the root node. Now we will repeat this process until the element is found. So we will repeat it for this node, for this node, for this node. Similarly, when the element is found or when we reach to the element which we want to search, we will print element is found. Otherwise, if the element is greater than the leaf node element, then we will print element not found. So in this way we can search a element in a binary search tree very easily. So now we will try to understand the second operation of binary search tree, that is the insertion operation, with the help of an example. We have taken an example here. The elements are 12, 34, 5, 1, 15, 6, 7, 13, 4 and 53. Now the first element we will always take as the root node element. So 12 becomes the root node element. Now comes 34. As we have seen that the numbers larger than the root node element always are on the right side of the root node. So 34 will come on the right side of 12. So here comes the 34. Now comes 5. 5 is smaller than 12, so it will come on the left side of the root node element. So here comes 5. Now the next element is 1, which is smaller than 12, then comes 5, and 1 which is also smaller than 5. Therefore it will come on the left side of 5. Now the next element is 15. 15 is greater than 12, but 15 is less than 34. So it will come on the left side of 34. So here 15. Now the next element is 6. 6 is smaller than 12 here. Now 6 is greater than 5, so 6 will come here. Now the next element is 7. 7 is less than 12 here. 7 is greater than 5 here. Now 7 is again greater than 6. So 7 will come on the right side of 6. So 7 is here. Now the next element is 13. 13 is greater than 12 here. 13 is less than 34 here. 13 is also less than 15. So 13 will come on the left side of 15. So 13 is here. Now the next element is 4. 4 is less than 12 here. 4 is less than 5 here. 4 is greater than 1. So here 4 will come on the right side of 1. Now comes 53. 53 is greater than 12 here. 53 is again greater than 34. So 53 will come on the right side of 34. So in this example we have learned how to create a binary search tree and how to insert elements with the help of an example. Now the next operation of a binary search tree is the deletion operation. In deletion operation there are 3 cases. This operation is somehow complex. Now we will study the case 1. Case 1 is if the node to be deleted is the leaf node. Leaf node means that the node has no childs, neither the left child nor the right child. So for example, we have to delete the node. This is an example of a binary search tree, and we are supposing that we have to delete the node 2. So we will simply delete the node. So after the deletion, after the operation performed, the binary search tree will look like this. Here this 2 node is deleted. Now the case number 2 is if the node to be deleted has only one child. For example, let us suppose that we have to delete the node 5. We can see that the element 5, the node 5 has only one child, the right child, which is 6. So when there is such kind of case, so we have to do we have to copy the child to the node and then delete the child. So we will do that. We will copy 6 in place of 5 and we will delete the child node. So after the operation performed, the binary search tree will look like this. 10 here the value of child note is copied and child note is deleted. Now comes the case number 3. This is the most complex case, which says that if the node to be deleted has two children. Now, for example, suppose that we have to delete the node 20. 20 has both the child left as well as the right child. So what we have to do here? We have to find the in order successor of node, then copy content of in order successor node and delete in order successor. So before seeing this, we have to understand what is an in order successor. So for that we have to understand in order traversing, which is L D R. L stands for left child, D stands for data, which is the node, root node data, and R stands for right child. So when we create the in order traverse of this search tree, it will look like first comes the left, which is 6, then comes the data 10. Again here it is the data, so first left 15, then comes data which is 20, and after that right child which is 30. Now what we have to do is we have to find the in order successor. This is called the in order traverse. In order traverse. In order successor means the element after the element which is to be deleted. So we have to delete the element 20. So here the in order successor of 20 is 30. So what we have to do, we have to copy the content of in order successor to the node and we have to delete the in order successor. So after the operation performed, the binary search tree will look like here 10, here 6. Here we will copy the content of in order successor, which is 30. So here 30, here 15, and the in order successor is deleted. So these are the 3 cases of deletion of an node in binary search tree. Now we will see the advantages and disadvantages of binary search tree. First, advantages. Binary search tree is an optimal searching algorithm using which we can search desired element very efficiently. Disadvantage. This algorithm requires the list to be sorted, then only this method is applicable. Thank you guys for watching our video and we hope that you understand. Thank you.